Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you to the next session of the series of C refresher videos. In the previous session, we talked about the basic data types in C like character, int, float, and double. We discussed how the variables of these types are stored inside the computer memory. We talked about little endian and big endian. We talked about the representation of signed integer types in 2's complement and the floating types in IEEE 754 standard using 32, 64, 128 or maybe 256 bits. We have also seen the range of values that these different data types can store. Let me write on the board as well. Review of data types and their representation. Well, we also have talked and seen the header limits.h that defines constants for size of integral types, while float.h defines constants related to the floating point arithmetic. I probably missed something, and that is, other than data types, all the variables in C also have a storage class associated with them. Storage class. Every variable in C also have a storage class other than the data type associated with it that provide info about their location and visibility. The first and the most common storage class is called auto, which is the default as well. By default, all variables that you create are local to a block or a function. These variables are discarded whenever you exit from that block or from that function. You can use the keyword register with automatic variables. The variables that are declared register are automatic and, if possible, are stored in CPU registers for quick access. If you do not write auto, it is considered implicit. The second is static. This is a bit tricky. You can make a static variable within a function. And at the same time, you can create a static variable outside a function as well. If a variable within a block or function is declared with static keyword, it will retain its value across exit from and re-entry to the block or function. So after the function invocation again and again, that variable which is declared static within a function retain its value. Variables declared outside all blocks are normally called the global variables. They are accessible at any point after their declaration. Again, you have two options. The first is you declare a variable with outside a function with static keyword. You can declare a variable outside a function without static keyword. If you declare a function outside all the functions with a static keyword, this gives them internal linkage. Internal linkage. By internal linkage, I mean that those variables are not accessible outside that .c or .o file in which they are created. And if you declare a variable without a static keyword outside a function, it gives them external linkage. That is, they are accessible in the entire program, in all the .o files. Well, the third storage class is extern. Declaring a variable with extern keyword anywhere gives it external linkage. Then when this discussion will remain incomplete if I will not talk about the volatile keyword. Well, this is the second thing which I probably missed. We do talked about let me shallow now. Type specifiers. What we missed, what is known as the type qualifier. The type specifiers are the character, int, long, float, signed, unsigned keyword. And the type qualifiers are const and volatile. Well, basically type qualifiers indicate some special properties of the variables being declared. For example, const, which is very common, is a type qualifier that makes the variable to be placed in the read-only memory. And this increases the opportunities for optimization. The volatile qualifier tells the compiler that a variable value may be changed at any time by an external source outside the program. For example, if I say, let's suppose, volatile and date, by making date volatile, it tells the compiler that be watchful, this may change by another program. So whenever you are going to access it, you must access it keeping in view that it's while you might have changed. At times you might come across something like this, like volatile const int, let's suppose a grid reference, a 6-figure grid reference of my house. Once given this type qualifier, this means that the value of the variable location cannot be modified by the program itself. However, it may be altered by another program. So these are some of the missing links I missed last time. Let me move on to the next board. and talk about, let's suppose, type conversion first. Type. Well, there are two types of conversion that might occur. One is implicit and the other is explicit. Dear students, where an operator has operands of different types. For example, let me say that, consider this C instruction with a long value divided by an integer value, and then adding an integer value multiplied with a float value, and then subtracting this with from a double value. We have different operands, and we have different operands of different types. Once an expression contains different data types involved, they need to be converted to a common type. And this is done automatically. Since this is done automatically, so it is called implicit conversion. Implicit conversion. Let's suppose that once these two integer and floating point values will be multiplied, the resulting value will be a float, the bigger data type out of these two. When this long is divided with this integer, the resulting type will be long, the bigger data type out of the two. When these two results, long and float, will be added, the resulting data type will be float. And finally, when this result float will be subtracted from this double value, the final result will be of double type. That means a lower type is converted to the higher type before an operation proceeds. A character is converted to short, a short to int, int to long, long to long, 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 long to float, float to double, double to long, double, and so on. However, this is not the case for the assignment operator. Once this double value will be assigned to this x, its fractional part will be truncated. You will have loss of precision as well as loss of data, maybe, in case of implicit conversion that takes place after the assignment operator. Let's talk about the explicit conversion as well, which is also known as casting. Casting is a way to convert a variable from one data type to another data type. Its syntax is type name in bracket, and then we have the expression. Let me write some examples for your understanding. This will cast this 7.5, a floating point value, to an integer, and of course a 7 will be assigned to x, no matter if x is a float or a double type. Before this division takes place, this 21.3 will be converted or casted to int, 4.5 will be casted to int, and then they will be divided, and then the result will be assigned to the variable x. In this case, once this plus operator will be evaluated, both these will be converted to float, and then the final result will be converted to int and then assigned to x. In this example, this ch1 will be first converted to int, and then this add operation will be carried out. So this ch2 will also be converted to int. The final result will be an int which will be assigned to x. Students, you might have used certain built-in typecast functions that are available in C, like a to I, a to L, and a to F, that normally converts a string to integer, long, and float respectively. Okay, let me change board. Let's have a brief summary of operators now. Operators in C. This is just an overview of the things. I assume that you have undergone with a basic course in a programming language like C. Well, you must all be knowing that an operator is a symbol that operates on the operands. C language is very rich in built-in operators, which can be divided into categories like the arithmetic operators. You have the negation operator, unary, the pre and post increment, the pre and post decrement, the multiplication, the division, the remainder, plus and minus operators. Then we have the relational operators, the less than is equal to, greater than equal to, double equal to, which is used to compare, not equal to as well. Then we have the three logical operators, which are not, which is a unary operator, and logical and logical or. Then we have the bitwise operators. These are the operators which are normally not taught in the first year courses. They are the bitwise and, bitwise or, bitwise XOR, bitwise not, left shift, and the right shift operators. You have the assignment operators. Is equal to, plus is equal to, minus is equal to, multiplied is equal to, divided by is equal to, left shift is equal to, right shift is equal to, and is equal to, or XOR is equal to, not is equal to, and so on. Finally, there are certain other operators which doesn't fall in this category. I am writing them as miscellaneous. The size of operator, the address operator, the dereference operator used with pointers, and the ternary operator. I will be concentrating on the bitwise operators, but before I start talking about the bitwise operators, let me overall talk about three important properties of all these operators. Let me move on to another board. Properties of operators. The first property is the arity of operator. The arity of an operator means the number of operands it can take. For example, a plus plus is a unary operator. This plus is a binary operator. Another property is the precedence of an operator. Right, students, if more than one operators are involved in an expression, like 1, let's suppose greater than 2, plus 3, and logical and 4, the precedence of operators decide which operator will be evaluated first. For example, over here you are seeing plus, which is the arithmetic operator, the greater than sign, which is the relational operator, and double ampersand, which is the logical AND operator. And their precedence is first the plus operator will be evaluated, then the relational operator, and then the logical operator. So it will always be better that you should write something like this. 2 plus 3 should be evaluated first, then this operator will be evaluated, and finally we have 4. And of course this means 1 greater than 3 plus 2, 5, which is false, that is 0, and we have this, and so this results to false. Remember, in C, 0 means false and anything else means true. After precedence, we have associativity of operator. This property of an operator is used when 2 or more operators in an expression have the same precedence. It can be left associative, or it can be right associative. Let me take different color and show you an example. For example, plus and minus, we all know that has same precedence. So how will you evaluate 7 minus 4 plus 2? So you have two options. One is you used left associativity and evaluate it like this: 7 minus 4 first and then plus 2. And maybe you use right associativity, that is, you do 4 plus 2 first and then you perform the subtraction. In this case, the answer will be 7 minus 4 plus 2 is 5, and in this case the answer will be 4 plus 2 is 6 and 7 minus 6 is 1. Now we all know that this is the correct result. So that means there is an associativity associated with every operator, and with plus and minus, these both operators are left associative. Let me change color and show you another example. Let's suppose I say 2 hat 3 hat 2. This is the exponent operator. Okay, so what this will be evaluated to? Some of you might evaluate it to 2 hat 3 first and then hat 2, which is, they assume that exponent operator is left associative, and this will result to 2 hat 3 means 8 and 8 hat 2 means 64. Some of you might think that this is exponent operator is right associative, so they will perform 3 hat 2 first and then they will perform this exponent. So 3 hat 2 means 9 and 2 hat 9 is 512. So if you try it in a C program or on a calculator, you will find this result. That means the exponent operator is right associative. Well, gentlemen, to perform correct mathematics and to write correct expression in your C programs, you must have a very fair idea about these three properties of operators: the arity of operators, the precedence of operators, and finally the associativity of every operator. Now let me move on to what I wanted to do today, and that is bitwise operators. Well, dear students, after having a bird's eye view of all the C operators in general, let's go into the details of bitwise operators, which are sometimes missed in the first year programming course, mostly taught in our colleges and universities. But these bitwise operators are extensively used in low-level programming courses like system programming, and their application areas can be, for example, a very common place where their use is checking file permissions. As you all know, those of you who have taken the OS lectures, that every file has a 16-bit structure associated with it, with the lower 3 bits telling you the read, write, execute permission about others, then the 3 bits with read, write, execute permission about group, then the other 3 bits with read, write, execute permission about the owner. Then we have special bits, saved SUID bit, SGID bit, and the sticky bit, and then finally we have 4 bits for that determines the file type. So if you want to check out whether a particular bit of this variable is set or not, or if you want to set or reset a particular bit of this variable in a C program, you need to have the mastery on the bitwise operators. Whenever you want to do low-level device control, you need to have a mastery of the bitwise operator. Whenever you are writing programs related to error detection and correction, whenever you are writing programs that deals with data compression algorithms, or maybe encryption algorithms. They all deal with bits. And before I proceed, let me make sure that you do not confuse the logical operators with the bitwise operators. Let me change color. We have the logical operators, as you all know, the 3 logical operators: the logical NOT, the logical AND, and the logical OR. And we have corresponding bitwise operators as well. We have the bitwise NOT, the bitwise AND, and the bitwise OR. And other than these 3, we have the bitwise exclusive OR, the left shift and the right shift. Remember, the logical operators, these they treat their operands as 0 as false and any other value as true. So if we have an A variable over here and a B variable over here, so if A contains 0, it will be treated as 0. If A contains anything else, it will be treated as non-zero. And similarly this operand as well. It will not operate on the bits. And the final result will either be 0 or 1. On the contrary, bitwise operators operates on bits of their arguments. Okay, so let me move on to another board and show you a brief example of that clarifies the idea of bitwise operator. Let me give a title as Understanding Bitwise Operators. The first one is not. Let's see not of 5. You can write 5 in 8 bits as the upper 4 bits 0, then we have 0 1 0 1. If I perform a NOT, that will result in making the 0 bits as 1 and making the 1 bits as 0. So in a C program, if you perform something like this, let's suppose unsigned char ch is equal to 5, and then you do ch is equal to not of ch, and then you print the value of ch, you will get some different value, and that value will be this 1 will not be there and this 4 will not be there, so that will be 250 if I'm not wrong. So not simply switches the bits. The 1 bit is made 0 and the 0 bits are made 1. Then we have AND. For example, if I say 5 and 4, this is a binary operator. It takes two arguments. So 5 0 0 0 0 and 0 1 0 1, and 4 is in 8 bits something like this. And if I use an AND operation on it, it will be, that is 4. And similarly, I can use the OR, and of course this will result in 5, and I can perform XOR. So the behavior of XOR is, if let me do it for you. If odd number of bits are 1, then the result is 1. If even number of bits are 1, then the result is 0. Over here there is no 1. No 1 means 0 1 and 0 is even, so the result is 0. So the behavior of XOR is the resulting bit is 1 if odd number of bits are 1. The remaining two are the left shift and right shift. Let me move on to the other board. Understanding bitwise operators. And fifth one is left shift. If you left shift a number with a value, let's suppose 2, let me write down 5, 0, 1, 0, 1. This means push in 2 0 bits from the left. Push in 2 0 bits from the left, 0 and 0. And this comes over here, and this comes over here. This bit comes over here, this bit comes over here, this over here, and this over here. And these two bits are lost. Remember, there is no rotate function in C. The last is the right shift. Before I move on to the right shift, the behavior of left shift is that once you left shift a number, it is multiplied by the number of times that it's shifted. I've done it incorrect. This one is here. It should be 1. And then this one is over here. Sorry. This should be 1. So 1, 2, 4, this weight is 4, 8 and 16, this weight is 16, 16 and 4 is, if I add these, this is 20. So if I do a left shift by 1, it means multiplication with 2, and if I left shift with 2, it means multiplication by 4. So you multiplied 5 by 4, which is 20. So every left shift multiplies by 2, and every right shift, of course, divide by 2. Let me do the same for this right shift. 0, 0, 0, 0. Let me 0, 1, 0, 1. So this time it will be right shifted. So 2 zeros will be pumped in, and 0, 0 and 0, 1. This 0, 1 will move out. So the result is 1. So if you right shift by 2, that means divide by 4, which is 1. One important thing that you should keep in mind is that for signed numbers, whenever you do a right shift for signed number, you pump in whatever is there in the most significant bit. So if it is a positive number, 0 will be pumped in, and if it is a negative number, 1s will be pumped in. While for unsigned numbers, you pump in zeros. This right shift is normally called the logical, while this one is called the arithmetic. To keep things simple, left shift always pumps zeros, and right shift pumps in whatever is there in the most significant bit. Okay, so let me change board again. Let me tell you some important concepts related to the AND operators. If you bitwise AND any variable with 0, you get a 0. If you bitwise AND a variable with -1, you get x, and if you bitwise AND a variable with itself, you get x, and if you bitwise AND a variable with its negation, you get a 0. Let me repeat the same for OR as well. If you bitwise OR a variable with x, you get an x. If you bitwise OR a variable with -1, you get -1. And if you bitwise OR a variable with itself, you get x. And if you bitwise OR a variable with its negation or complement, you get a 1. Let me do the same for XOR as well. If you bitwise XOR a variable with 0, you get an x. And if you bitwise OR a variable with -1, you get not of x. And if you bitwise OR a variable with itself, you get a 0. And if you bitwise OR a variable with its negation, you get a -1. These are some important properties that you might be using in the later part of some advanced courses. Okay. So finally, let me give you some application areas of Bitwise Operators, some applications. Of Bitwise Operators. The first application I would like to touch upon is swapping. We all know that we can swap the value of two variables, x and y, by taking a third variable, like temp is equal to x is equal to y, and y is equal to temp. Some of you might also have swapped value of two variables using arithmetic operations. Like for example, x is equal to x plus y is equal to x minus y, and x is equal to x minus y. Or you might have used the multiplication and the division. X is equal to x into y is equal to x divided by y, and x is equal to x divided by y. Both these two options, A and B, works fine, but they may cause overflow. And this B may not work when y is 0. So let me show you another way to swap using bitwise operator. And the bitwise operator I'm going to use for swapping is XOR. For example, x is equal to x hat y is equal to x hat y, and x is equal to x hat y. Let me do that for you. Let's take a sample piece of code. Let's suppose I'm going to do this. Let's suppose x is equal to 5 and y is equal to 10. And let me write down just 4 bits. 5 in 4 bits can be written as 0, 1, 0, 1 from the most significant side, and 10 as 1, 0, 1, 0. So let me use this. So if I do x hat y, if I perform x and y, so this line will give me x is equal to x hat y will give me 1, 1, 1, 1. And this line will give me y is equal to x is all ones and y is 1, 0, 1, 0. So this will give me 0, 1, 0, 1. And this x hat y, x is equal to x contains this and y contains this now. And if I bitwise OR these two, what I get is I get a 1, a 0, a 1, and a 0. And this is 8, 9, 10. So x has a 10, and this is 4 and 1, 5. So y has a 5. So you see, a swap has occurred. You can easily write a code of these. I'm not going to the terminal and writing code for this. That will take more time. And let me move on to another application area. And the second application area is, for example, if you want to check ranges of various data types. Probably we have seen this in a previous session. However, for the review sake, let us just compute the range of unsigned character variables. For unsigned character variable, we know that it takes about 8 bits on a machine. So the min value is of course 0, and the max value is 2 power 8 minus 1. So let me write a C line of code to do this. And max value 1. I left shift this with 8 and perform a minus 1. So this is equivalent to this. We know left shift by 1 means multiplication by 2, and left shift by 8 means multiplication by 2 power 8. And this 8 is because the character data takes 8 bits. And if I want to find out the range for unsigned int, so we will place 32 over here. Okay. Let's see another application area. Checking status. Alphabet. So this is one thing which we talked about earlier as well. Many times we need to check if a specific bit in a variable is set. We can do this by a two-step procedure. Step 1 is we create a mask, and step 2 is result is equal to the variable and the mask that we have just created. The variable is that memory part whose bit we want to check out. Well, what is masking? Masking is a technique of zeroing out all the bits which are not of our interest and make the rest of the bits 1. It is similar to the way that you mask your face. You mask your face, less your eyes with a mask. Let us suppose that we have a 8-bit unsigned character variable containing 11, 1, 0, 1, 1. So this is a variable. Let's suppose, let me write here unsigned character ch is equal to 11. C piece of code. And we want to check if bit at index 2, index 0, index 1, index 2, 3, 4, 5, 6, and 7. I want to check out the bit at index 2 is set or not. So the first step is that we need to create a mask for the job, which is 1 at index 2 and rest all zeros. So the mask for this task will be, this will be the mask, a value having 1 at the bit of our interest. In C, if I want to create a mask, then this line of code will do the job. I'm using unsigned char because I'm keeping things simple with 8 bits. Mask is equal to 1 and a left shift of 2. So if I give a left shift of 2 to a variable containing 1, it will give me this value. Remember, this one is treated as int, which is of 32-bit, but we only need 8 bits, so it's okay with us. After we have created the mask, we just need to do a bitwise OR. So let me do a bitwise OR. I perform a bitwise OR and I get this. No, I need to do a bitwise AND for this task. I get a 0. Let me write a C line of code for this. Unsigned character result is equal to ch and mask. So when we perform this task, the result will be 0. The result 0 means that the bit was 0. If the result is something else, that means the bit was 1. Let me do that example as well. Let's suppose that we have the same value 0 0 0 0 1 0 1 1, and this time we want to check this bit. So we place a 1 over here and 0 over here, and once we do an AND, we get 4 zeros, and this is not 0, this is, of course, value is 8. So that means the bit at this position is set. So using this logic, you can always check out whether the bit in a variable at a particular location is set or is not set. Finally, one more thing before we close: setting a bit. Dear students, sometimes we need to make a specific bit 1. We can also do this by following the same two-step procedure. As we have done in checking the bit. Step 1 is we need to create an appropriate mask. Step 2 is that we bitwise OR the variable with the mask that we have just created. Let me do it with an example. Let's suppose that we have 11 in 8 bits. Let me write the code as well at the same time. Unsigned char ch is equal to 11. Now I want to create the mask. The mask to set the bit. Let's suppose that I want to set this bit. This bit is right now 0. I want to make it 1. So the mask is this. And this mask can easily be created by this C statement. Unsigned char mask is equal to 1, and we give this 1 a left shift of 2. Let me wrap this. Okay, and finally I need to do an OR. So I do an OR 0 0 0 0 1 1 1 1. You see, I have successfully set this bit, and in C a statement to do this is unsigned char ch is equal to ch bitwise or mask. Right, and when you can extend the same logic to set a range of bits in a variable, or maybe to check if a range of bits in a variable are already 1 or not. Well, that's all, students. Hope today's session was informative. I wish you all the best. Happy coding and Allah Hafiz.